Aloha class, I got some coffee this morning. They keep on with that little buzzing sound, test, test, test. And it's a little late start we got going. You guys are all napping at home, getting a nice little breakfast in. But I'm here pumping out the videos, so let's keep rolling. Today we do L'Hopital's rule. It's not La Hospital, it's L'Hopital's rule. Okay, you say that wrong in class, major point deductions. All right, here we go. 4.7, using L'Hopital's rule for determining limits of indeterminate forms, okay? So we're kind of going to go back and we're going to look at limits that we did in the past. And for certain limits, we have a quicker way of doing them. And L'Hopital's rule allows us to do it. You pronounce that name wrong, La Hospital, and you're not allowed to use it. All right, here we go. So let's get this started by going a little old school. Okay, old school limits and a little bit of some review here, okay? And let's do these limits. What I want you to do is hit pause and do these limits the way we did them at the beginning of the year, right? First thing we would do is always direct sub. We get 0 over 0. That is called an indeterminate result, okay? And when that happened, what we did is we did something else, DSE, right, class? And that would be an x minus 2, an x plus 3, all over an x minus 2. Remember, that result means there would be a removable discontinuity. Remove that bad boy, and we get the limit as x approaches 2 of x plus 3, and we get an answer of 5. Believe it or not, there's another way to do that bad boy. Okay, we'll touch on that in a little bit. Let's look at this one right here. Ooh, if I do use direct sub, I get infinity over infinity. Guess what? That is an indeterminate result. How else do we do this guy? We do a little EBM, right, class, where we take the first term of the top with the first term of the bottom, do some math, plug in. That's going to have a horizontal asymptote at y equals 0, and so the answer to the limit is 0. Remember this bad boy. Let's do direct sub. I get 0 over 0. Oh, snap. But that's the smiley face, right? So we know that answer is 1. And then our last one, we do direct sub. We get a 0 over a 0. There's no math you can do for that bad boy. The only way to actually do that one is to graph it. Look at what's happening as we approach from the left, as we approach from the right. And if you do that for that problem, you get an answer of 2. Okay, so all 4 of those are indeterminate results. This fourth guy and the third guy you really can't do, right? We have a little cheat that we use for the third guy. For the fourth guy, the only way to do it is graphically. Okay, but for the first two, we were able to use some algebraic techniques or end behavior model system to help us to get that answer. Okay, so we have this little dude called L'Hopital, smart dude, way back in the day that figured out almost a quicker way to do some of these guys. All right, so in each example above, the limit takes on what we say indeterminate form, okay, which is 0 over 0 or infinity over infinity. You notice that only the first example was evaluate. Oh, I just said all that stuff. Okay, here we go. L'Hopital's rule. Okay, there's 3 things that must be satisfied in order to use this. Okay, f and g, number 1, have to be differentiable functions on the open interval. Okay, so they've got to be able to find a derivative of those bad boys. Okay, next, the top and the bottom limits must both give me 0 over 0 or infinity over infinity, which are indeterminate results, right? And the last one is you've got to be able to take some derivatives of those bad boys. So 1, 2, and 3. You can make a little list right here if you want to. I'll say it again. 1, f and g are differentiable. 2, the limits both have to give indeterminate results of 0 over 0 or infinity over infinity. And 3, you must be able to take derivatives of those bad boys. Okay? Oh my gosh. There's like a cricket up there. If that thing falls on me, whoo, is that going to be a video to remember? I'm going to start freaking out. All right, here we go. Example 1. Oh, snap. That looks like that's the problem we did before. Well, let's see. That top guy, well, believe it or not, let's just get after this bad boy. If I can find the derivative, that means, hey, L'Hopital rule is going to work out. But let's use direct sub as always. Boom. Dude, let's do a little L hop, right? That's a little left-handed hop right there, okay? So we can use L hop because we get 0 over 0, and I can take some derivative of those bad boys. Now, one thing that the AP wants you to do when you use L hop is you have to split that limit up into the numerator and the denominator. So let's go ahead and take derivatives. Derivative of the top will give me 2x plus 1. The derivative of the bottom, and I'm going to split it up like this. And you have to do this year. We didn't have to do it last year, okay? And then we take the limits of both of those guys, and what do we get? We get, oh, snap, 5 over 1, which is 5. That's the answer I got from the above one, right? Go ahead and check it out. We did. All right, here we go. Let's check the next one. Direct sub, infinity over infinity. Oh, snap. Do it, class. Do it, class. All right, and then what do I have to do? I have to split that limit into the numerator, take the derivative, split that limit into the denominator, take that, sub in that infinity. I get 3 over infinity. What's that, class? That is 0. Okay, and believe it or not, a question you might have is, what if I do L-hop and then it doesn't work and I still get an indeterminate result? Believe it or not, you can keep on using L-hop or L'Hopital's rule as long as you get an indeterminate result. Okay, you can just keep on using it. Okay, let's keep rolling here. This video's gotten to be a little bit too fun. Oh, here's the other guys, right? Our C and our D. The limit, okay, we get a little 0 over 0, which before we had to use that smiley face rule, but maybe since I got an indeterminate result, I could use L-hop. All right, so let's go ahead and do it. That would be the limit equals to, as x approaches 0 of, that would be cosine x, all over the limit as x approaches 0 of uno, ichi, 1. And if I use my direct sub, I get cosine of 0 over 1, and that would be 1 over 1, which is 1. Oh, snap. I don't need that little smiley face anymore. What you want, right? All right, let's do this next guy. Direct sub gives me 0 over 0. What's that mean? Class, do it with me. L-hop. Okay, and so what do we do with that bad boy? We take the limit of the numerator, which would be, oh, snap. That's a chain rule. Did we learn that? Yes, we did. We got the chain rule. So that would be e to the 2x times the derivative of 2x, which is 2 all over 1. Now let's, ooh, snap, shame on me. I was wondering if we've all learned the chain rule yet, and we all did. But remember, you've got to split it up into these 2 separate limits and able to use L'Hopital's rule. Now we plug in that 0. I get 2 e to the 0 all over 1, which is 2, which is the answer we got from board. Pretty darn cool, isn't it? And fun. Every time, if you want to use L-hop, you got to do the L-hop. So hopefully right now you're like, does L-hop, L'Hopital's rule, always work? Well, it does if you get 0 over 0 or infinity over infinity, right? Let's take a look at these bad boys. And what you always want to be very careful is that first thing you're supposed to do whenever you evaluate a limit, which is direct sub. If I direct sub here, I get e to the negative infinity over infinity, right, class? Which would be 1 over e to the infinity all over infinity, right, class? Which would be like a 0 over infinity, right? Or 1 over e to the infinity times infinity, which would be 0, right? I don't get an indeterminate result with that one, so I'm just donezo, right? You do not use L'Hopital's rule. If you use L'Hopital's rule in that guy, you might get it wrong, so be very careful. Only use it when you get an indeterminate result. Now this one here, let's go ahead and plug it in. We get a little infinity over infinity, so let's go ahead and use L-hop. Okay, so we got limit equals as x approaches infinity of 1 minus cosine x all over the limit as x approaches infinity of 1 plus cosine x. Plug in infinities now, and whoa, it kind of like oscillates, right? Because it's 1 minus, and then that guy's kind of oscillating, right? And on the bottom is 1 plus cosine to the infinity, and cosine, they kind of oscillate. So we kind of get a DNE above, right, because it kind of oscillates. We kind of get a DNE below because it oscillates between two things. So bang, I don't get any answer for that one. So those are 2 examples where you can't use L'Hopital's rule. And we actually would have other techniques to do them, okay? But in terms of AP Calc, you are covered. That is it with L'Hopital's rule. L-hop that bad boy if you want to use it, remember, and it is L'Hopital's rule. Aloha and see you in class.